What do you see before you? Do you see a barren wasteland? Or do you see a stark landscape of beauty? What if I were to tell you this area was teeming with life? What if I were to tell you a plethora of stunning plant and animal life lay hidden before your very eyes? This area is the Mojave National Preserve, and it is currently threatened by human-driven pressure. My name is Keith Gaddis. I'm a graduate student studying species in the Mojave here at the University of California, Los Angeles. Using a combination of ecological, remote sensing, and genetic tools, I am trying to help preserve the Mojave from ongoing threats to its survival. In order to know how species will respond to a changing environment, we must first know more about the past history and current limits of species in this zone. To explain how I and my colleagues are doing this, we should start at the base and work our way up. The Mojave Desert is one of 4 major U.S. deserts. The hottest of the group, much of the Mojave is commonly referred to as the high desert, as large areas lie at elevations greater than 3,000 meters. The desert runs across 3 states, occurring mostly within the California landscape. The total area of the desert is 22,000 square miles. It is incredibly arid, receiving less than 13 inches of rainfall annually. Temperatures throughout the desert are very extreme, going from below freezing in the winter and resting well above 120 in the summer months. Over the last 20 years, all of the Southwest has observed a decline in rainfall. For the already arid Mojave, this is disconcerting, as multiple climate models have predicted an increasingly arid future for this area. Additionally, development in the desert is ever increasing. Most of the natural water sources are already diverted to major towns. Man's impact has led to dramatic fragmentation and isolation of a once pristine area. In the face of this, with the assistance of collaborators at UCLA and the National Park Service, over the last 5 years I have been studying the impact of climate and landscape on the viability of a representative species within the Mojave Desert. Our study species is Catclaw acacia, a common southwest shrub that has a patchy distribution normally restricted to dry washes, where previous rainfall has left a sandy stream bed behind. The major characteristics of this species are representative of numerous other shrub species in this area. Thus, understanding how it is affected informs us about the response of the community as a whole. What is now essential is an understanding of the current limitations of species to react to these dramatic changes. With such rapid damage occurring, survival depends on maintaining existing populations and the ability to move when habitat becomes altered or damaged. For plants, this isn't as easy as picking up your legs and moving. Plants move via seed and pollen dispersal. Thus, observing their normal rates of movement is a bit tricky. Having access to genetic tools helps us solve this problem. We can measure genetic differences between plants to estimate the degree to which their ancestors have moved and how landscape or climate have affected this movement or limited their reproduction. We do this by taking our data and displaying it on maps. Looking at areas where we know our species is, we can plot out the dominant avenues of dispersal. By comparing those areas with lots of movement with those areas with very little, we can identify the dominant landscape features that facilitate or impede dispersal. What we have found for Catclaw acacia is striking. This tree has a history of widespread movement, yet much of this has been dramatically affected by the surrounding climate. We find that movement through the hotter areas is very limited, and at lower, hotter elevation, acacia produces fewer seeds and thus moves less. This is troubling given the future of this area. If temperature and aridity continue to rise, catclaw and other species like it, or that depend on it, will have an increasingly restricted range. As we have observed a history of widespread movement for this species, this will mean a dramatic shift. We continue to study this species to provide land managers with the best option for curbing the effects of human-driven environmental change. Only through a joint effort of community action and scientific inquiry can we hope to preserve the majestic beauty of areas like the Mojave from our own actions.